For this problem, there's not a straightforward way to attack it. I actually tried several things before I came up with something that worked. Here's what I decided to do. I decided to take this and rewrite it as secant squared x times secant x over tan x dx. Now, if you take the secant squared, or I'm sorry, the secant over tan x, and you rewrite it, secant is 1 over cosine, tan is sine over cosine. So if we put this together, we get 1 over cosine times cosine x over sine x. So this becomes cosecant x. So I can rewrite my integral then as integral of secant squared x and times cosecant x dx. Now I'm going to use integration by parts on this, because secant squared is something we can integrate easily. So if I let my dv be secant squared x dx, and I let u be cosecant x, then the derivative of cosecant is minus cosecant x cotan x dx, and from this v is just tan x. So I'm going to use that to rewrite this. So the integral becomes uv, so that's going to be cosecant x tan x minus integral of v du. So integral of tan, cotan, cosecant, and it's negative. So the negative, I'm just going to change this to a positive. And this is going to be cosecant x, cotan x, tan x. Now, cotan x and tan x are reciprocals of each other, so they just cancel out. Cotan x times tan x is 1. So what I get here is cosecant x tan x plus integral of cosecant x. Now the integral of cosecant is not one that we know, but it is on the formula sheet that we have. So if we look at our formula sheet, we can get the integral of cosecant x is natural log of cosecant x minus cotan x. And that's our answer. Now, I got this problem out of a different textbook, and when I did this, I checked my answer to see if it was right, and the answer that they had in the back looked different. The answer that they had in the book was secant x minus natural log of cosecant x plus cotan x dx. Or, I'm sorry, not dx, plus c. So we need to look at this and see if we can figure out how these two things are equivalent to each other. So we've got two parts to look at. The secant and cosecant tan are the same. You can see that because cosecant x tan x, if you write that out, cosecant is 1 over sine, and tangent is sine over cosine. So those cancel off, and it just leaves us with 1 over cosine, which is secant x. So this part and this part are equivalent. Now we've got to show that this Well, this and this are equivalent. So let's look at that. If we take cosecant x minus cotan x, notice there's also the sign here. If I'm looking at natural log of this was positive. If I made this negative, that would change this thing to the -1. So in other words, I could rewrite this as minus natural log of 1 over cosecant x minus cotan x. And now I need to try to show that 1 over cosecant x minus cotan x is the same as cosecant x plus cotan x. So it'd be nice to get rid of this denominator. So I'm going to multiply over here by cosecant x plus cotan x on top and bottom. Alright, when I do that, let's see, up top I get cosecant x plus cotan x, which is exactly what we wanted, over, multiply this out, you get cosecant squared x minus plus cosecant cotangent minus cosecant cotangent minus cotangent squared x. And if we look at our Pythagorean identities, we'll see what we need. From this one here, if we take cosecant squared and subtract cotan squared, we're left with 1. So this is equal to cosecant x plus cotan x. Therefore, this logarithm is equal to that one. So the answer that I got and the answer that they got in the back of the book are the same.